My name's Casey. I'm from a little startup in Amsterdam called MX3D. First of all, a show of hands, does anyone know what MX3D is? That's not too bad. Hope for better, but anyway. So my background is in architecture. I'm from Australia. I've been living in Amsterdam for about 2 years now. I moved there for the job. And I don't do anything that an architect would do in a company such as MX3D. I'm just going to preface it with this short video because it explains it much better than I could. Unfortunately, I don't think we have sound today, so we'll make do. The audio isn't that good on it anyway. So the reason I like to start with this video is because that's the founders of the company when they were young. Obviously not, but that's a little terrible joke that I like to make. MX3D is exactly like these children. We're just a bunch of adults that haven't grown up. And none of us do what we're trained to do. We're all just united by a shared passion for innovating and having fun together. So in fact, we're a 3D printing startup, and we work with two very simple technologies. Well, not simple, but it's a robot and it's a welding machine. We started by duct taping the welding torch onto the end of the robot and thought, how hard can this be? Little did we know it was very difficult. So we get there eventually, but in order to think about how we could manufacture difficult objects, I might just go back into the company's history a little bit and explain how we got to be a 3D printing company. So there's a designer from the Netherlands by the name of Joris Laman. He's quite famous for making beautiful curvy chairs that cost 100,000 euros and sit in art museums around the world. So essentially he needed a cheaper way to make these chairs. And along with some people working in his design studio in Amsterdam, they got frustrated with things such as FDM or SLM printing because they were not accurate enough or too expensive or too slow. And so they thought what they could do with a robot that gave them a lot more freedom in terms of design and manufacturing. But with this fabulous idea, they needed a poster project that would actually show that the technology was worth something. So they'd made a few novel things such as 3D printing a bike or making, some beautiful screens that sit in art museums, but they weren't necessarily meaningful projects. And in order to get sponsors such as Autodesk on board, we had to come up with a daring project, something that was difficult. And so the founders all paid for themselves to go over to San Francisco to Autodesk's Pier 9 headquarters, and sitting at a bar the night before the meeting, this was literally the sketch on the back of the cocktail napkin. Going, wait, a bridge is perfect. We're from Amsterdam, there's heaps of bridges there, there's water everywhere. The city council is really open-minded, they'll probably say yes to it. And bridges are really, really hard to engineer, so let's do one with a manufacturing technique that's really not been verified. So it was a big moonshot, essentially. And we didn't quite know how to get there, but we knew that we'd need the help of software companies, 3D printing companies, robotics companies, every single aspect of the business, we have had someone show us how to do it. Because we were just a bunch of naive children, not sure what to do. But where we started with was with topology optimization. So for all the civil engineers in here, you guys are probably very familiar with the process. But we began by modeling our simulations on the way that bones grow. So that our design was really, form follows function. And once we had met the engineering criteria from the outset, we could use generative design technologies provided by Autodesk that would allow us to iterate really quickly through hundreds of different options, knowing that every single different design met the criteria for safety. And that was a really, really exciting way of working. In the construction industry, we're all hyper aware of this tension between the designers and the engineers. and for so long it's been a war. But this project really was a change. It's been a symbiotic relationship from the start, and we've both walked out of this project now having the bridge finished, feeling really proud of what we've achieved. So we began by scanning the location, 3D scanning it, and what was really important about this is that the canal walls in Amsterdam are hundreds of years old and are crumbling to pieces. So we needed a really, really accurate representation of these in order to make a digital model that would interact well with the site. So using 3D scanning, it allowed us to build 3D models that would, once finished completion and being placed on site, would fit seamlessly. So this was, the way that the data was allowing us to work more intelligently. But when it came to, all of this was design work at this point. When it came to actually making it, we collaborated with various engineers from universities such as Bologna and Imperial College in London, and they took every single sample of our material you could imagine. So piece by piece by piece by piece, they tested it, they squished it, they stretched it, they crushed it, and then came up with a really dense database showing how our material would perform. It's a stainless steel, or it was a stainless steel before we welded it, heating it up, cooling it down, heating it up, cooling it down. And so it's a new material, essentially, and we have not certified it. But what all of this testing gave us was essentially a digital model of how the bridge will function under stress. So this engineering model, what you see, the blue lines are lines of tensile stress, whilst the red lines are lines of compressive stress. So using this, when we then switch over to see the final bridge in our workshop in Amsterdam, you can see that this same curve, this thick curve running along the side here, matches that line of compressive stress. So inside that thickened part are extra stiffening pieces. So our design is working with the inherent strengths of the material, and it's allowed us to design around the weaknesses of it. So this kind of data-driven design and data-driven engineering has been quite a revolutionary process for us. Now, I can't say it's been a profitable project at this point. It's an experiment. But the data that we have gained from this is invaluable, because now the next bridge and the one after that will be ridiculously cheap in comparison, because the R&D is essentially none. So I'm going to show a video which unfortunately doesn't have any sound, but let's see. So that is, in fact, the way that the material, the digital model of our material, performed when load was applied to it. So that's the list of sponsors, and only about half of them made it onto the page. I think one last thing I'd like to focus on following on from that video. So I've talked a bit about the engineering process and a bit about the design process, but not enough about the data. So the third and final stage of this project, once we place it on site in the middle of the red light district, Tourist Central, is that we're going to equip it with a really advanced sensor network. And so all of these sensors will be plugged into the Forge cloud computing network, and from this, machine learning algorithms will be built in that will begin to be able to correlate what these sensors are picking up. So the bridge will know when 10 people are on it, when 50 people are on it, when 2 bikes are on it, and when 5 people are jumping up and down, 2 meters from the left-hand side. And then the idea is that we build interactivity into the object so that in real time the bridge can respond to what is being what's happening on it. So this is something that's still experimental. We don't yet know what we're going to do, but we have our own sort of little hackathon that's going to happen once we place the bridge, and we're really excited to see what everyone comes up with out of this and what people do with this data that we're going to be putting out open source on the web. So it's an exciting project, primarily because of the way that data, design, and engineering are interfacing in this really symbiotic way. And I hope that this can be a bit of a poster project for what you guys will, the students will come out and work on in their own careers, and what these companies are doing. I think I'd just like to say thank you guys for welcoming us here. I hope that I've provided some morsel of inspiration, and if there are any questions, please.